Hello everyone, this is Mulong, and here we go for the presentation of UIED, the User Interface Element Detection Toolkit. First of all, let's start with a story of John and Bob. John is a creative designer keen on coming up with fantastic web design ideas. But there is a small problem, that he knows nothing about coding. So he works with Bob, a professional coder, to let him implement his design into working websites. Bob, on the other hand, is excited as well, but for sure. So John hands his design image prototype to Bob, and probably several days later, the working version of John's fancy design would become true. Sounds quite familiar for web and app developers, right? But things would be different if those two brothers use some auxiliary tools, something like image to code. Image to code here is just a general reference for those tools that synthesize code from input GUI image. It's a quite popular topic in relevant research fields now, by which the developer can get rid of trivial and repetitive work of GUI development and save time for more important work. So how does it work? Basically, it comprises two steps: the element detection and code generation. Through these two stages, the reusable code can be generated from the input GUI image within several seconds. Quite magic, right? Let's see another story. So Bob, the poor guy, finally finished the development of his application. And now, before getting off work and enjoying his life, he has to gather some tester to test the app. So he comes to Sam, a tester in the company, and hands the application to him for testing. Sam starts his work by clicking all the buttons on the app and then check if the app behaves as it should does. For example, he clicks the log on button and expects the input pane page will jump out. Quite a normal day for a tester, right? However, things would be different again with some auxiliary tools. For example, the auto tester. Again, the auto tester here is just a general reference for such tools. The auto tester detects and recognizes all or certain type of buttons on the app and automatically click or activates them to compare the app's action with the expectation. The tool can significantly reduce the time of testing to several seconds, which is an actual efficient progress for GUI testing. With the help of the auto tester, Sam's day would be really easier. Well, as long as he wouldn't get fired because the team may not need people tester anymore. So, from the above story, we've seen how the technology can facilitate the developer and the chaos pains for developers and testers, in particular in GUI development. And of course, there are even more such stories in the industry. Among them, a common need is the accurate GUI element detection. For example, the image code application needs to detect the position and shape of the GUI elements for generating the code. And the auto tester also needs to first detect where the target elements are before actually testing them. However, although the GUI element detection is as important as we see, there are still some problems with it. First, there is no off-the-shelf GUI-specific detection approach that's easy to use. Second, there is no mature and universal approach suitable for all kinds of GUIs, such as mobile and web. Finally, for those who attempt to apply deep learning models to the problem, it's quite time-consuming and laborious to collect training dataset for training models, and it's also hard to be universal. Therefore, Here we present our web-based toolkit for GUI element detection, the UIED. UIED is an easy-to-use platform for GUI element detection. It takes GUI image as input and outputs the JSON format detection result for further development. We propose our own approach based on our observation of GUI's particular properties. It's a top-down and cost-to-find process. It reaches the state-of-the-art result in GUI element detection. And because it's based on old-fashioned computer vision or algorithm, it doesn't require massive dataset to train, and is easy to fine-tune some key parameters for different kinds of GUI images. According to our empirical study, which is also published in our main paper, various detection approaches perform differently on different GUIs. So, UIED equips with 5 detection techniques and allows the user to synthesize detection results from multiple methods. On the landing page of UIED, the user can choose to use the provided examples GUI images to try the tool or upload their own UI as input. UIED supports the detection of various GUIs, including mobile app, web, and even some hand-drawn designs. But note that all the deep learning models are just trained on mobile app GUI, and only our own approach can achieve decent performance in other kinds of GUIs. Besides, the user can adjust some key parameters in our own approach. The parameters would vary slightly in different GUIs. UIED provides the user with a novel dashboard to edit the detection result. In the dashboard, the user can move the element by drag and drop. Resize element and delete them. The UIED collects all the detected elements in the UI kit, where the user can access and reuse them if needed. The user can also use other approaches to process the input GUI again. And the detection result will be collected in the UI kit again. So the user can synthesize the results from multiple approaches. Finally, UIED will export the detection result as a JSON file format that is easy to use in future. Here we can see some examples of GUI element detection result from our own approach. We hope the UIED can provide an easy way for users to detect the GUI element from GUI design image and be used in future development and research. Thanks for your listening.